How's it going? Welcome. This is Math from the Void, where knowledge is power, answers dissolve questions, exponentials bloom out of nowhere, and everyone who arrives with an open mind can find their own place in the infinite. This is the true test of your knowledge of exponential functions because we're going to combine several of the techniques that we've used before in this Calc prep assignment. We're going to combine some quadratics with exponentials, and then we're going to make sure that we're solid on these rules for exponents, just so that the mechanics of this problem make sense. Now, here is the problem for today. This is the only problem for today. It may seem very simple to look at. 2 to the x plus 2 to the negative x equals 5. This is definitely exponential. Why is it definitely exponential? Because we have a variable in the exponent, right? And in case it's difficult to see, let me do a better job at writing this. This is 2 to the x plus 2 to the negative x equals 5. So it's clearly exponential because we have a variable in the exponent. It's not obviously quadratic yet. In order to reveal that, we need to explore the exponent rules for this negative power. So let's go back and check out the rules for negative exponents. The rule for a negative exponent is if we have x to the negative n power, this is the same as 1 over x to the positive n power. So taking that into consideration, our equation looks a little something like this. 2 to the x plus 1 over 2 to the x equals 5. Now we need to use our developed instincts in mathematics. We can't access the denominator. We're not able to reach that x that's in the denominator. So we need a way to bring everything to the numerator. And just like if we were trying to cancel a fraction, like a 1/3, we would multiply everything by 3 over 1. We're going to multiply everything here by 2 to the x. That means we're going to multiply the left side by 2 to the x, and we're going to multiply the right side by 2 to the x. You can either put that in parentheses with the 2 to the x, or you can simply multiply 2 to the x to each of these terms, like this. 2 to the x, 2 to the x. We kind of just squeeze it in there to multiply it, but that does look a bit sloppy, so let's write some clean work. We're going to multiply the entire side by 2 to the x. And that's going to cancel when we distribute this. That's just going to leave us with a 1. Here we have 5 times 2 to the x. And next we're going to take a look at multiplying numbers with the same base. Because when we distribute 2 to the x into 2 to the x, what happens there? Do we call it 4 to the x? Do we call it 2 to the x squared? What do we do? Do we call it 2 to the x plus x? These are all valid. If you have a to the n times a to the r, let's use different letters. X to the a times x to the b. That means we have a copies of x and b copies of x being combined together, all multiplied. So in total, we have a plus b copies of x. Now, since this is 2 to the x times 2 to the x, we're going to have 2 to the x plus x, or in other words, 2 to the 2x. But for our purposes here, it's going to be a little better if we just keep it as 2 to the x and then write squared, which is the same thing as 2 to the x times 2 to the x. That's what squared means. It means 2 to the x is multiplied by itself twice. So let's write it as 2 to the x squared. And now we have the opportunity to turn this into a quadratic. Still don't see it? Let's make a substitution. Oops. So we're going to turn this into a quadratic equation. Let's make the substitution. Let's call it u equals 2 to the x. And in this case, sometimes we write let in math. Let u equal 2 to the x. Then what we're looking at here is we're just looking at u squared plus 1 equals 5u, which is definitely a quadratic. We can solve this very easily. Let's get everything over on one side. And then let's use the quadratic formula. Negative b plus or minus the square root of b squared minus 4ac, which is 4 times 1 times 1, all over 2. And so overall, we're going to have 5 plus or minus the square root of 21 over 2. So we have two solutions for u. For you, just for you. We have 5 plus square root of 21 over 2, and we have 5 minus the square root of 21 over 2. Now we need to consider both of these because our solutions do not end with u. These are not our final answers. Remember, this is the substitution that we made. U is equal to 2 to the x. So really we have 2 to the x equals 5 plus square root of 21 over 2. And we have 2 to the x equals 5 minus square root of 21 over 2. We have to make sure that this is not a negative value because exponentials could never be negative, and it's not negative. Square root of 21 is smaller than the square root of 25, so it's smaller than 5. And if we do 5 minus something smaller than 5, we have a positive. All is good. So what do we do now? We can finish this off with a logarithm because we're trying to get to the exponent. Remember how we get to the exponent? We have to turn things into logarithmic form. This will be log base 2 of 5 plus root 21 over 2. Now, when I was in school, our handheld calculators did not have different bases. We had to use this change of base relationship. And so what we really had to do was you could take any type of log of the inside expression. So we would take a log of this with any base, like the base that our calculators had, like base 10 or base e, so you could just use ln over log base 2. And similarly, we'll have log base 5 minus square root of 21 all over 2, and we'll divide that by log of 2. Now, calculators these days, they allow you to use whatever base you'd like. So go ahead and plug that into a calculator. I'll do that very carefully. It's very important to be careful when you're using a calculator, because some students don't really have the ability of checking whether or not their answers are reasonable, and that can be a little risky. So we're going to take a log of this, 0.68045, and then we're going to take a log of 2, which is 0.30103, and we can divide. We get approximately 2.2604. It's 040, so I'm just going to leave it as that. And our other solution, let's see, we have 21 square root by 2 Okay, I'm doing log base 10, so if you're using a different base on the top and bottom, you might have different numbers than I do. Interestingly enough, this is just a negative of what we looked at earlier. That is pretty interesting. That the log of 5 minus root 21 all over 2 is the negative of 5 plus square root 21 all over 2. Anyways, we're going to divide this by log of 2, which we have from the other calculation, 0.30103. And, therefore, I know that I'm just going to get negative 2.2604. All right, there we go. Now, why does this make sense that these two are solutions? One's positive, one's negative. If you look at the original equation, what was the original equation? So if I have this be the 2 point, whatever it was, 2.26 or something, and then I have this be the negative 2.26, that's going to be the exact same answer as if I just switched them where this is a negative and now this one's a positive. So it makes perfect sense that those two would be your solutions, especially if there are two of them due to it being a quadratic. Okay, so this was a very brief journey into the void, but we're going to have to leave it at that. Coming up next in the Calc Prep assignment is going to be plenty of trigonometry. So this is your warning. Review your trig before you come to the next journey. See you next time.